Chetri, PhD scholar from SMIT, is going to present an e-presentation on realization of smart city using 5G cognitive radio, and I am the main author of paper ID SOC 158649, which is published by International Journal of Science and Research with ISSN 231970664, and the topic of my presentation is realization of smart city using 5G cognitive radio. Coming to the introduction part, the evolution towards 5G is considered to be the convergence of interest services with legal mobile networking standards, leading to the commonly used term called mobile internet over heterogeneous network with a very high connectivity speeds. The objective of cognitive radio is to sense the spectrum from the real-time environment and detect the utilized spectrum called white space. And these spectrums are allocated to the secondary users, verifying the policies. The MIMO technique is most promising technology that offers considerable increase in data bandwidth with an extra transmission power. And this paper details about the 5G technology which can be used in realization of smart city. And coming to the block diagram of 5G wireless communication system, 5G system is a normal to the basic communication system, but the magic part is that it uses smart antenna technology and the sensing technology. The key technology includes MIMO integration to emerging technologies like device-to-device port, heterogeneous networks-based centric architecture for millimeter wave range for developing future generation 5G standard for wireless cellular. The advanced digital signal processing such as channel estimation and interference cancellation are the basic part of this smart antenna. So overall, the 5G communication system is the intelligent technology which provides higher flexibility and efficiency. Spectrum sensing. Generally, cognitive radio is the intelligent technology which senses the spectrum and location. The main goal of cognitive radio is to sense the underutilized spectrum by the secondary user. In 5G communication system, the devices such as smartphones which searches the occupied spectrum in the form of base station downlink signal and take the instruction from the cellular system. Cellular system is quite sophisticated and achieve high spectral efficiency. 5G system will be based on dynamic spectrum sharing such as detect and avoid and the dynamic frequency selection. In this smart sensing, we have used N6841A is a sensor which is used to detect the white space, and it is allocated to secondary user with zero interference, as primary user has the right to access the spectrum. The simulation is done using the system view. The range between the first peak and the last peak of the spectrum is the white space, which is backend, and the same can be used by the secondary user without interfering the primary user. Coming to the MIMO, massive MIMO is defined as a system where all antenna configuration is made in the digital domain and hence can simultaneously be configured for multi-beams and array. Antenna is utilized as base station side only. In 5G system, the multiple antenna can be considered in both transmitter and receiver section because it has the capacity to reduce the co-channel interference. The MIMO has the tendency to direct the transmitted power in only one direction, as the 5G system uses the small cell base station with the delay spread can be greatly reduced. MIMO technique is evolving technology that offers considerable increase in data bandwidth without any extra transmission power. Due to these properties, MIMO technology will be a vital aspect for cellular and wireless communication standards. Capacity achievement. The capacity can be achieved by the combination of the three parameters: spectral efficiency, spectrum, and spectrum reuse. The spectral efficiency can provide capacity of 5 times, and it can be achieved through the use of massive MIMO. Recent innovation in cellular air interference design through 3GPP LTE provides spectral efficiency performance that is very close to the Shannon limit. To meet the growing traffic demand, the system capacity net per square meter must be increased by either adding more network nodes, densification, or making additional spectrum available. To that end, it is mandatory to deploy dense network by means of heterogeneous networks of low power nodes, small cells such as picocells and femtocells. However, the available spectrum below 6 GHz is limited, and there are practical limits due to propagation for how small these cells can shrink. Therefore, it is necessary to use the spectrum above 6 GHz for higher capacity waveform processing. The FBMC uses the synthesis filter bank in the transmitter side, which uses the polyphase networking, and the IFT operation of the multi-carrier signal and analysis filter bank in receiver side. And this section uses the sub-channel equalizer, by which preferred signal recovery is possible under ideal channel conditions. FBMC does not use the cyclic prefix, so it can oversee the bandwidth. Two notable drawbacks of OFDM are a loss in spectral efficiency due to cyclic prefix. Coming to the cellular architecture of 5G communication system, in this figure we have shown the heterogeneous network for smart cities, which consists of node cells with heterogeneous characteristics and capabilities, macro cells, small cells such as femtocells and picocells, device-to-device user equipment, and machine-to-machine users, etc., which will result in a multi-tier architecture. Due to increasing complexity in network management and coordination among multiple network tiers, the network nodes will have the capability of self-organization, such as interference cancellation, spectrum sharing, and the power management. The communication efficiency in 5G systems will be improved by incorporating techniques such as EthNets, interference cancellation, and spectrum reuse. Full duplex communication and energy harvesting capacities will breed many challenges for designing and testing the initial internal chips and front-end modules for 5G device. 5G device. The ability to pair users can be enhanced with interference mitigation, receiver, or MIMO technique to remove interference. The heterogeneous network can be applied for all the use such as traffic services, residential use, smart grid, health services, and many more, which results in complete smart city realization. Coming to the conclusion, this paper reinforces the notion of smart city based on the context platform for a major role in next generation network. In this paper, we have shown the overview of several emerging technologies for 5G wireless networks. The technology discussed in this paper, such as millimeter wave and massive MIMO, will also impact the design and development of 5G networks. Future 5G cellular network will definitely be a combination of different enabling technologies. In this paper, we have also discussed some potential key technologies that can be deployed in 5G wireless system to satisfy the expected performance requirements, such as cognitive radio. And so these are the references for this paper.